Hello intellectual, I am SK Thakur and you are watching this channel in Digital Maths Academy. Today's topic is basic trigonometry. Trigonometry is originated from the sides of right angle triangle, which are also known as P, B and S, perpendicular, base and hypotenuse. The relation among P, B and S are already explained in Pythagoras theorem. If you haven't watched the video, I have already given the link in the description box. Kindly not to forget to watch the video, that is Pythagoras theorem and Pythagorean triplets. Basic trigonometry. Trigonometry is combination of the three words tri, gono and metry. Tri indicates three, gono represents angles and metry represents measurement. So you can say the measurement of three angles, but the angles are not possible without the sides. So we can say trigonometry is the measurement of all the angles and the sides of a right angle triangle. So trigonometry can be defined as trigonometry is the branch of mathematics which deals with the measure of the sides and angles of right angle triangle. In a right angle triangle ABC, with respect to the reference angle theta, AB is perpendicular and BC is base, and AC opposite to 90 degree, the longest side is always hypotenuse. Now trigonometric ratios. Let's we have P, B and S are the sides of a right angle triangle with respect to a reference angle theta. Then we can find or we can write 6 ratios: P by H, B by H, P by B, H by P, H by B, and the last one is B by P. Here the ratio of P over H is known as sine, S-I-N-E. That of B by H, it is cosine. That of P by B, that is tangent. Here the reverse of P by H by P, it is cosecant. That's cosecant. Reverse of B by H, that is H by B, is known as secant. That of P by B, the reverse is B by P, is cotangent. Cotangent. But without reference angle, all these values are incomplete. So we can say here the reference angle is theta here. So we can say that here sine, that is short form of sine, is sine, S-I-N, sine, and we can write here theta. So now sine theta is incomplete, so that's complete. Similarly here, this becomes cos theta, here it becomes tan theta. Here cosecant, that becomes cosec theta. Or sometimes we write here C, yes, C also. Here secant, we can write it becomes sec theta, and that of cotangent, it becomes cot theta. Now the relation among them. So we can define trigonometric ratios as the ratio of the sides of right angle triangle with respect to reference angle are known as trigonometric ratios. Here we should not have to forget that if we have sine theta here, then the reference angle is theta. If there is a cos A, the reference angle is cos A. Cos A and cos B, if the reference angles are different, then they are also different. So cos A and cos B are different. Now the relation among PB and H. As we have seen, H by P, that is cosec, and P by H is sine. So we can say cosec theta into sine theta equals to 1, or we can say sine theta into cosec theta also equals to 1. Likewise, we can write here B by H into H by B, and that is equals to 1. So it gives cos theta into sec theta equals to 1. Likewise here we can write P by B into B by P, that's 1. So it becomes tan theta into cot theta, that's equals to 1. So from this relation we can say that here, from here we can write sin theta equals to 1 by cosec theta and cosec theta equals to 1 by sin theta, right? Similarly, from this relation we can write cos theta equals to 1 by sec theta and sec theta becomes equals to 1 by cos theta. Likewise, from here tan theta equals to 1 by cot theta and cot theta become equals to 1 by tan theta. Now we know that P by B equals to tan theta, right? So we can divide both sides up and down by, of course we can divide up and down by h. So we can write here P by h by B by h equals to tan theta, yes, that becomes, and this relation becomes tan theta equals to sin theta by cos theta, right? Because P by h is sin theta and therefore B by h is cos theta. So tan theta becomes sin theta by cos theta, and cot is just opposite to tan, that's the reverse of tan. So we can write here cot theta equals to reverse of sin by cos, that becomes cos theta by sin theta. Next, some more relations. From the Pythagoras theorem we can write p square plus b square equals to h square. H square minus p square also we can write equals to b square, and the last one h square minus b square equals to p square. In p square plus b square is equal to h square, when you divide both sides by h square here we get, and after the separation of the base we can write p square by h square plus b square by h square equals to 1, right? And p square by h square, that is p by h whole square, that gives sin square theta plus cos square theta equals to 1. Similarly, from h square minus p square equals to b square, when we divide both sides by b square here, and when we separate the base, that becomes h square by b square minus p square by b square, that becomes 1, right? And h square by b square, that is h by b whole square, that gives sec square and the reference angle theta, then sec square theta minus, that is tan square theta equals 1, right? Likewise, when we divide this part both sides by p square, then you can get, after the separation of the base, h square by p square minus b square by p square equals to 1, of course you can get, and h square by p square, that is h by p whole square, that is cosec square theta, and b by p whole square, that is cot square theta, that gives 1. Likewise, from this relation sin square theta plus cos square theta equals to 1, we can write here sin square theta equals to 1 minus cos square theta, right? And cos square theta becomes equal to 1 minus sin square theta, and when you remove square, that becomes sin theta equals to under root 1 minus cos square theta, that of cos theta becomes equal to under root 1 minus sin square theta. Likewise, here we can write sec theta equals to sec square theta, first of all 1 plus tan square theta, and tan square theta becomes equal to sec square theta minus 1. So when you remove square, that becomes sec theta equals to under root 1 plus tan square theta, and here tan square theta becomes equal to tan theta, that is tan naught square, that becomes equals to tan only here. So we can write tan theta becomes equal to under root sec square theta minus 1. Likewise, from here we can write cosec square theta becomes equal to 1 plus cot square theta, right? And cosec theta, yes, you can remove square, then under root here 1 plus cot square theta, and similarly cot square theta becomes equal to cosec square theta minus 1, and cot theta equals to under root cosec square theta minus 1. we can remember the previous relation of trigonometric ratio by a sentence, that is, some people have curly brown hair turned permanently black. Here, yes of some remains sign, P of people remains P, H of have, that is yes. Similarly, C cos, B H, T for tan, there's a P by B, so you can easily remember the formula of sine, cos and tan. And here reference angle is compulsory, so without reference angle it's not possible to compute any trigonometric ratio. And that of cosec is opposite to sine, so we can write here cosec theta equals to H by P, that of sec theta equals to H by B, and that of cot theta equals to B by P. All the derived basic formulae are listed here. Kindly not to forget to remember and read it. Some important point related to trigonometric ratios. The first number, trigonometric ratios don't have any unit. If we take any trigonometric ratio, for example cos equals to P by H, right? So it's a ratio of the same unit, that is base is also in length, H is also in length, so it is, you can say that unitless. Next one, sin A whole square equals to sin square A, that is not the square of the angle. Similarly, that you can say that here tan theta, it's any power, that's power n, equals to, we can write here tan to the power n theta. Let another example also, we have here sec 20 degree and its power is 3, so we can write here sec to the power 3 and 20 degree. Sin A never be equal to sin B unless A and B are not related. So we can say that here, if we have any angle that's a cos theta, that cannot be expressed into another angle, that is never be equal to cos alpha if theta and alpha are not related. Trigonometric ratios follow all the rules of algebraic expressions. So we know that here A plus B whole square, as you know, equals to A square plus 2AB plus B square, right? So we have here sin theta plus cos theta, so we can apply formula, that is sin square theta plus 2 sin theta dot cos theta, and we can write here cos square theta, isn't it? Again now, if we have we can take common also. For example, if we have here x square plus xy, so we can take common x and it becomes x plus y. So if we have here tan t square A plus or minus, doesn't matter, tan theta into cos theta into tan A, right? So we can take here common tan A only, right? Tan A we can take common, and just after taking common tan A, we can write here tan A plus tan theta dot, yes, we can write here cos theta. So we should not have to forget that tan A and tan theta are different, so we cannot take common tan theta because tan theta is not in the first term. So hope you have enjoyed this video. So if you like, then please like, subscribe and share. Please encourage me. Thank you. Have a nice time.